Hello and welcome to this AWS webinar. My name's Ian. I'm a technical evangelist with Amazon Web Services here in Europe, and I'm going to be your host for today's session. The topic for today's webinar is development and test on AWS. But before we come to that, I just want to give you a little bit of information about the webinar programs that we run here, and also talk to you about where you can get the materials and how you can submit questions during today's webinar. So this is a webinar series called Journey Through the Cloud. This is an intermediate series of webinars as far as the technical level is concerned. It's really intended to introduce you to common use cases and stepping stones that you can use to help you adopt AWS. We're going to share some learning from some of the customers that are already using Amazon Web Services. We're going to try and give you some best practices that can help you bootstrap your first projects on AWS and help those to be more successful. We have another webinar series called the Masterclass series, which you can also access via the same channel that you're using for the webinar today, and you should receive a mail about that if you've signed up for this one. The next one's going to be next week, where we're going to be looking at some advanced techniques for using EC2, the Elastic Compute Cloud. So do stay tuned for that and drop in for the Masterclass if you want to dive deep on a few AWS services and understand a little bit more of the detail about how you can use them. You can submit questions throughout this webinar as usual, and if we have time at the end of the session, we'll try to answer a few of those. But if not, don't worry, we will follow up on the questions and we'll get a member of our team to contact you if you've got a question. We have your contact details when you registered for today's webinar. So if we don't have time to answer your question during the webinar today, we will get back to you with an answer in the very near future. And lastly, the materials from this webinar will be made available for download immediately afterwards, so you can grab the slides. There are quite a few cross-references in the slides to places, other resources where you can find further information about some of the topics we're going to discuss today. So do feel free to grab the materials, and of course there'll be a recording of this webinar available just a few minutes after it's finished as well. So if you want to share the webinar with any colleagues that didn't see it, or you want to watch it again because you didn't absorb everything, then you're more than welcome to do that. You can view the webinar on demand just a couple of minutes after it's finished. Okay, so let's get started with the content now we've done that bit of housekeeping. The topic for today's webinar is about development and test workloads being run on the AWS cloud. We're going to explore the benefits of using AWS for this kind of workload. They're a really good workload to use for your first deployment on AWS, because they're obviously non-production use cases. So you can have the opportunity to learn a little bit more about how AWS works, what the potential benefits could be for you and your organization. And you can do that in a controlled way, which won't necessarily have impact on production services that you're providing for your customers or for your users. So we see a lot of customers start their adoption of AWS with these kind of workloads. And there are some real advantages for using cloud computing in general, but AWS specifically for these kind of workloads, because elasticity and automation can provide a real advantage in the development and test cycle. And hopefully through the course of today's session, we'll explain to you why that's the case and how you might be able to get some benefit from that yourselves. Okay, so here's the agenda for today's session. We're going to have a look at why AWS is a great platform to use for development and test workloads. We're going to talk about AWS services that can be employed to make your development and test processes more successful and also to make them more efficient. We're going to talk about some common architectural patterns that AWS customers tend to deploy when they are running development and test workloads on AWS. And then lastly, we're going to come to a few resources that you can use in order to learn more. Okay. So the first section is obviously why AWS for development and test. And obviously, there's a huge number of facets to the execution and operation of development and test activities within the IT application lifecycle. I've thrown a few of those facets up on this slide here, but you could really put hundreds more. You know, there are a great many different aspects of development and test when you're trying to run these workloads. But we find that most of them have common traits. There are a couple of themes that often come to the fore when you're considering why and whether you should run your development and test workloads on the cloud and on the AWS cloud specifically. And we just want to dive into those in a little bit of detail. So the first thing we're going to look at is the disposable nature of AWS services. And when I say the disposable nature of the services, I mean that you're obviously not committed to use of AWS for a long period of time. You can dip in and out of it as you see fit. You can start and stop resources and just pay for the amount of resource that you're consuming, and you don't have any penalty as a result of doing that. So it's great for projects that start and stop frequently, for any workload that needs to run for a short period of time, as is often the case in testing, for example. And it's also good when you have a known state that you're going to constitute your environment from. So you're working with golden masters, which again is very often the case when you're in the development cycle. You want to have your environment in a well understood condition before you start working on it. Those three characteristics are really well aligned to the way in which you can use AWS, and we're going to dig into that in a little bit more detail in the course of this session. Second thing is, you've got this characteristic of having numerous environments for these kind of workloads. So you may need many environments to support the development of one application. And you see this quite often with commercial package software, where you may need a development, a QA, a UAT, and a production environment. And that's also the case when developing custom software in many, many cases. You can also require additional environments for things like regression testing of prior versions, or recreation of, let's not call them bugs, error conditions in software that may have been developed some time ago. So you can end up with a situation where you need lots of environments for a short period of time, and AWS is really good for that. Also, you have the capability with AWS to preserve known configurations, and together these things can help you deal with overlapping development cycles, which are quite a common characteristic of software development, as I'm sure you'll know. So what we believe really is that the fact that you're going to have these characteristics of disposability and the fact that you're going to have numerous parallel environments required means that the cloud is a great place to run your development and test activities. And let's go into a little bit more detail about why that is, and we're going to do that in three ways. We're going to talk first of all about the characteristic of AWS that allows you to take a lot of capacity when you need it. We've got what is effectively unlimited elastic capacity, and there's a huge amount of resource there available for you to use when you need it. So you can take a lot of AWS services when you require them. You can also dispose of those services, throw them away when you don't need them, which can lead to some really strong benefits in cost optimization, and we're going to look at that in a little bit more detail during the session today as well. And then lastly, we're going to look about the opportunity that you have with AWS to preserve your environments for future reference, and we just talked about a couple of reasons that you might want to do that in the earlier session. But certainly we have a capability to provide very durable imaging and very durable storage of your environment, so that if you need to recall that environment at some point in the future, you can be sure it will be there and available for you. So we'll go through each of those areas in sequence. First of all, we'll have a look at this idea of being able to take a lot of capacity when you need it, and we're going to explore 6 different aspects here, starting with the elastic data center. So the building blocks for that, well, you may have seen something like this before if you've attended an AWS webinar previously, but these are the building blocks that are used to construct compute instances that are running on the AWS cloud. You start off with generic images, which are called ARMIs or AMIs, the Amazon machine image. You constitute an instance using that ARMI as your template, your base system. That can be a Linux or a Windows environment, and that from third parties. It can also be some other operating systems as well. Once you've got that default instance running, you can then customize that, and you can obviously deploy your application stack onto that. And at the end of that process, you can then refreeze that system image and create a new ARMI, which you can then repeatedly deploy to create systems that are in exactly the same state as the one that you've just built using your customization process. And that is one of the tools for enabling this kind of elastic delivery model, where you can build copies of environments or build environments that have very large horizontal scalability in a very simple and easy way. So bear that process in mind. We're going to refer to that a little bit more when we move a little bit further through the webinar today. This is the sort of environment you can typically build using AWS. So you can have an on-premise development team, as you probably do today, but rather than having an on-premise data center, you can make use of the AWS cloud, building one of these VPC, these virtual private cloud constructs, which allows you to set up complex network topologies on the AWS platform, and also to use, if you want to, your own IP address space, and to have private network connectivity, which can connect your development teams to the large amount of compute resources and other resources that are available to you within that VPC. And you can see this model here, the developers can connect into that environment using a secure connection, which can be either a VPN or it can be a private network connection using an AWS service called Direct Connect. So that's how your developers can access the resources that they need. And of course, with AWS, once they don't need those resources anymore, just shut down that VPC and you'll no longer be paying for any of those resources after that point. So it's very good for short-term project requirements where you want to build a data center, use it for a period of time, and then discard it with no commitment. So let's move on a little bit more. So take lots of it when you need it, throw it away when you don't, and preserve it for future reference. We're going to look now at spinning up environments on demand. So let's look at a case study first of all. This is a pretty popular PS3 title that was released a couple of years ago, Little Big Planet 2. Very, very large service, as many of these gaming offers are. You know, you get very, very high user volumes, extremely peaky. And as a result of the rise of online gaming, obviously you're no longer freezing the title at the point at which it ships. There's a continuous requirement to develop and innovate once you've shipped the title in order to retain the interest of your players. And Alex Evans is the CTO of a Sony studio called Media Molecule that was responsible for the development of Little Big Planet 2. And you can see in this quote here, he's talking about some of the benefits that his organization has managed to drive by using AWS for their development and test environments. Talking about flexibility, the ability to spin up test environments very quickly, which they use for beta trials, for QA, for localization, also during the general development process. And he's also talking about the low-cost aspects of using AWS. So we'll talk later on about another couple of references and also provide you with a resource where you can find out a lot more about customers that are using AWS for development and test today. So let's move on and look at this idea of spinning up environments on demand and what tools we can provide to make that easy for you to do. There's basically three ways to do this. The first is DIY, which we've just talked a little bit about already. So this is the traditional way in which you might manage EC2, AWS EC2 resources. So using those armies, those Amazon machine images, you can use snapshots, which are the capability to obviously take a known configuration of a system or of a set of data, snapshot that on the Amazon Elastic Block Store service, the EBS service, and then you can use that snapshot, either attaching it to a different EC2 instance or cloning it into an API, into an ARMI rather, an AMI, and using that to spin up instances that are copies of the one that you've just snapshot. So that's a mechanism for DIY. Also, we've got this technique called bootstrapping, which is passing startup time actions to an instance and using those startup time actions to configure an instance at the point at which it's created. It's a super powerful tool, and we're going to talk about that a lot more in next week's EC2 Masterclass. So if you're interested in exploring some of those techniques that you might use on the left-hand side here in the DIY section, then really advise you to come along next week because we're going to talk a lot more about those in next week's Masterclass. For today, we're going to focus a little bit more on the other two areas, which are Amazon Elastic Beanstalk, which is this idea of managed standard containers. Now, with this service, it's possible to give access to development and test environments to developers directly from IDEs, so they can push applications directly from Eclipse or directly from Visual Studio into the Amazon Elastic Beanstalk, into a pre-configured application container, which will then execute their code for them. We're just going to give you an overview of precisely what this service supports and also a little bit more detail about how it works. The third thing we're going to talk about is CloudFormation, which is a flexible service that allows you full control of complex environments using a templating language. So with this, you can generate environment specifications, which are in this declarative file format, execute those specifications through an engine, and that will then create a set of AWS services for your application to consume. And we'll come back and cover that in a little bit more detail. First of all, we're going to dive into the Amazon Elastic Beanstalk. So as I've just said, the Elastic Beanstalk provides for a mechanism for quickly deploying and managing apps on AWS. And the way it does that is by allowing you to deploy either directly from an IDE or directly from a source control system like Git or another source control system. You can push that code into the Beanstalk environment, and once you've done that, Beanstalk will take some actions and create a set of services that allow that code to be executed for you. It's super simple to use, and it currently supports 5 different languages, which are .NET, PHP, Node.js, which is obviously server-side JavaScript, Java, and Python. And the way that this works is you would push your web application package into Beanstalk as a deployment action. When you do that, Beanstalk will create a container within EC2 which contains this stack. So it will build the operating system for you, either a Windows operating system environment if you're pushing .NET code, or Linux for the other variants that we've just talked about. It will create a HTTP service and install a language interpreter for you. And it will then create an application service and allow your user application to be installed within that. But it does a little bit more than that. So the other thing it does is it also marshals and coordinates and creates the other AWS resources that are required to enable your application to be accessed in a reliable and scalable way. So it does things like adds an elastic load balancer. It will create an auto-scaling group, and it will populate that auto-scaling group with EC2 instances, and it will then wire those things together into the framework, and it will then publish a CNAME to enable users to access the application, and it will store logging data from the application inside Amazon S3 for later access. So you can see how that can give you a very, very simple way to deploy code for testing purposes and for development purposes and for prototyping purposes also, directly into AWS with really minimal requirement for any operations or configuration on your part. So it's a great tool for you to use for that. There's a lot more detail about Elastic Beanstalk at the link that you can see at the bottom of the slides here. And of course, if you download the slides after this webinar, you will be able to click through all those links and find the extra resources. So that's a quick summary on Elastic Beanstalk. Talk now about CloudFormation. So CloudFormation, as I've said already, it allows you to declaratively define your requirements for AWS services to support your application. And the way it does that really is that you create a JSON formatted file with a certain syntax and notation, which contains things like parameter definitions, resource creation, and actions that you want to take at configuration time. You then pass that file into the CloudFormation engine, and that framework will create the stack for you in the first time you push that file into it. It'll also manage stack updates. So if you change a CloudFormation template, push a new version of that template into your CloudFormation engine, then changes will be made to your stack that reflect that. So it will support differential addition and removal of services to and from your stack. So it's a pretty powerful tool from that perspective. Now, what you end up with as a result of executing that template can be a fully configured AWS environment, and there's huge support for a very broad range of different AWS services within CloudFormation. So you can use this obviously for building individual environments, but it really comes into its own when you consider that you can use CloudFormation to quickly and easily build repeated environments. So if you need separate but identical environments for development, for testing, for user acceptance testing, and for production, you can define a CloudFormation template once, and you can execute that repeatedly to create those multiple environments in an entirely consistent manner. You can even do that in different locations around the world using AWS regions if you want to do that. So it's a very, very powerful tool for minimizing the overhead of building multiple environments. And you have this JSON notation file, as we've already mentioned, that we use for that. And once again, you can find much more information about CloudFormation if you follow the URL that's at the bottom of this slide here. And as I said, you'll be able to download this deck after the webinar today and get hold of that. So follow that reference, and you can find out a lot more about how CloudFormation works and also how you can use it. There's actually a very large library of CloudFormation templates that you can access that AWS have created and contributed back to customers for them to use either as they stand or to use as the basis for more complex environments in a sort of modular way. So do take a look at the URL there, and you can find out a lot more detail about that. So talk there really about generic tools for managing custom code deployment and for the creation of environments for custom code deployment on AWS. Let's just take a quick look at packaged applications. So we're not talking here today solely about the development of custom code using programming languages. We're also talking about development and test activities for packaged applications. You'll know if you use use any of these apps, there's quite a bit of configuration work and customization available in these packaged apps, and often the vendors themselves recommend running multiple environments in order for you to minimize the risk of either making configuration changes or even supporting minor and major version updates. This is very common, for example, in the SAP environment, where you may have a development, test, QA, UAT, and production environment, and you may not need all of those all the time. So one of the benefits of the cloud, of course, is that you can stop those environments when you're not using them. You can retain their state, and when you need to use that environment again, you can spin it back up again, and of course only pay for it while you're using it. We have broad support for a wide variety of different products from SAP, and again, you can find out a lot more detail about support for SAP on AWS if you follow the URL that's at the bottom of the slide here. And similarly with Oracle, we have something called the APN, the AWS Partner Network, and there's a broad range of partners in the Amazon Web Services Partner Network that are offering services based on Oracle technology, and we have a wide range of customers that are running Oracle on AWS today. So if you want to find out more about Oracle applications on AWS, there's again, a URL you can follow there at the bottom of the slide, and you can get a lot more detail there about how customers are using AWS to de-risk the operation and, more importantly, the development and upgrade process for packaged apps using the AWS cloud. Excuse me. So let's move on now and talk about some frameworks and tools that you can use for development and test on AWS. And we really think there are sort of four components of this. So the sort of common development support tools that we see customers using include source control, and obviously it's possible to use AWS to run your source control repositories. Project management tools, and again, those can also be run on the AWS cloud. In many cases, we have customers, and you will have a requirement for build servers if you're doing continuous integration or even basic compilation of software products. You may want to have build server farms to enable you to do that. And then lastly, developer workstations. So we've obviously got a new product that we've recently announced for supporting the Windows desktop environment on AWS, which is called Workspaces. It's currently in limited availability preview, but I think it will come out of that quite soon. It's been in limited availability preview for some time now, so I'm not sure when, but it's very likely that it will come out of preview soon. And that can be a great tool for enabling you to spin up standard developer environments, including developer tools, and also for testing the client component of client-server applications, or testing the interaction between different browsers and web-based applications that you might have developed. So just consider that the workstation environment can also be part of the development environment in some cases. And a common pattern that we see for deployment is that customers will place these development support services, these tools, within AWS and leverage a variety of different AWS services in order to do that. And what you can see on this architectural construct here is customers got a source code repository, which is taking advantage of Amazon EBS, the Elastic Block Store that I talked about earlier, and they're able to use the snapshotting features of EBS to snapshot their source code repository and to keep those snapshots for a long period of time if required. So that's a pretty powerful feature. Customer's got a continuous integration server, and you can see from the architectural diagram here that that's a larger system. So it's possible, obviously, to have EC2 instances of different sizes, and continuous integration and unit testing can be a pretty computationally and I/O intensive workload. So you can obviously use a larger instance type there as appropriate to enable you to deliver your workflow in a timely manner, and you can then use the Amazon S3 storage service to deposit the artifacts that are created by that CI process. And then lastly, this customer's also got a project management server that they're running on EC2, and they've got that attached to an Amazon RDS relational database service instance, which is going to be running an Oracle, MySQL, or Microsoft SQL or Postgres database, which is supporting that project management application that they're running. So you can see how it's possible to construct your entire development support environment within AWS, and we'll talk about some of the benefits that can offer to you and your organization later on in the session. But that should just give you a flavor of a pattern that customers tend to deploy. Other thing that's pretty cool about using AWS for this kind of service is we have something called the AWS Marketplace. Now some people aren't aware of this, so this might be new to you, but if you go to aws.amazon.com/marketplace, you can find a website there, or part of the website there, which allows you to buy and install third-party software products onto the AWS cloud. And you can see here the product detail pages for Redmine and for Perforce, which are a couple of popular developer support tools. The great thing about AWS Marketplace is the products in there are billed and charged in the same way as Amazon Web Services. So you can pay for these software products by the hour as you use them. And then if you need to spin up an environment for a short period of time for a new team or for some temporary workers that you're going to have working on a project, contract workers that you're going to have working on a development project, you can buy and use your software that you need to support that short-term project on a consumption basis without having a long-term licensing commitment. And when you finish the project, you can shut the software and the EC2 AWS environment down and stop paying for it, which is pretty powerful. Of course, if you use a sensible account structure for your Amazon Web Services accounts, you can also consolidate and bucket all of your costs for your projects underneath individual AWS accounts. So it gives you cost control, but also good partitioning and visibility of your costs, so you can see which projects are costing what and control that in a really proactive way, which is, I think, a pretty unique feature, really. Then lastly, when we're talking about frameworks and tools, it's of course possible to integrate the kind of environment that we're talking about here with CloudFormation. So you could, and many customers do actually, create CloudFormation templates that are part of their deployment process, part of their integration process, and you can push out and execute that CloudFormation template directly from an S3 repository, an S3 bucket where you may have stored it. So your infrastructure build using AWS services and your code deployment can be integrated together, and you can have your infrastructure version controlled consistent with the version control that you use for your code. So that's a pretty advanced feature, but an extremely powerful feature when you consider it. So it enables you to make sure that your infrastructure model is synchronized with your software for deployment. So let's move on from frameworks and environments and talk now about testing at scale. Once again, there's 4 real components to this. So unit and regression testing, which is often part of the CI process. Load and performance testing, which could be done as part of CI, but could also be done periodically in response to demand forecasts that you might be generating for your application, or in response to a major version upgrade. Security, where you may want to create sandboxes for aggressive security testing. And then lastly, A/B testing, where you might want to assess the popularity or performance of different stacks and control the flow of traffic to 2 or more stacks in order to enable you to do that. We believe AWS can offer benefits across all 4 of those areas, so let's talk about that quickly. Let's start first of all with unit and regression testing, which, as I said earlier, can be a CPU and I/O intensive activity and can often take quite a long time to undertake complex suites of unit tests. So one of the really great characteristics of the cloud in general, and AWS specifically, of course, is its elasticity, and it costs exactly the same to have 1 instance for 100 hours as it does to have 100 instances for 1 hour. So if you have an opportunity to parallelize your unit testing activities, then do so, and you can use large farms of AWS EC2 instances to drive that drive the time taken to conduct those unit tests down very, very significantly. And of course, we've also got high performance instance types, which you might not want to acquire simply to run unit and regression testing, but you can access those by the hour using AWS. So you could have a high performance cluster compute instance with a huge amount of CPU and memory and high performance SSD disks in it, and use that as a target upon which you run these unit and regression testing workloads to try and drive the cycle down. Now 100 small instances for a period of an hour can cost as little as $8. So it's not expensive to do this. If you can achieve this parallelization, then that's a great way to reduce the elapsed time of your development projects, allowing you to iterate more quickly and obviously ship product more quickly. So really, really powerful tool that many customers use. Let's look now at A/B testing. So one of the other things that is possible to do with AWS is to build multiple environments very quickly. We've already touched upon how you might use AWS CloudFormation to do this, but you can, of course, once you've got those environments spun up, use them for deploying different versions of your application, and you can manage the inflow of traffic onto those different environments in a way which allows you to control who sees which version of your application, and of course you can collect logging data from different application versions and store that in Amazon S3 in a very durable way for later analysis. And we have many customers that are doing that. So it's a technique that's used for assessing whether or not a new version of an application represents an upgrade as far as user popularity, user experience, or performance or availability is concerned. And there's another way to drive load testing also on AWS. So in the load testing context, it's quite often popular to use large farms, banks of load generators to drive traffic to a website or another application, and use that to assess the performance of that application under these extreme loading scenarios. And this elastic characteristic of AWS really lends itself to that really well. So you can create large farms of compute instances that are running your load generation software. You can drive those towards copies of your stack that have been constructed for this purpose, and you can use that technique to assess the performance of your application under extreme load. We provide some tools. This is a tool called Amazon CloudWatch, which provides you with metrics from your AWS environment, and you can use those metrics to assess the impact of that kind of load testing scenario, monitoring CPU, disk utilization, read-write levels on your I/O, and you can also populate these metrics using custom data that you might gather on your instances, either from your application or from agents that you might locate within your operating system environment, for example, to assess how much memory might be consumed on an instance, or monitor queue depth or application robustness. You could capture those metrics within your application and push them into what we call custom CloudWatch metrics and monitor that stuff together with your CPU performance in order to assess whether or not your application is performing well under load. So a lot of techniques that you can use there to enhance the performance testing process. And just grab another gaming example here and talk to you about this. So Call of Duty, I'm sure you'll know this, is one of the largest entertainment franchises in the world. It's an Activision software product, a multi-platform game, which has been hugely, hugely successful. And Activision wanted to make sure that they wouldn't become a victim of that success. So they've used Amazon EC2 for large-scale simulations. And before they launched Modern Warfare 3, which was a couple of years ago now, they generated a load test which simulated them having 2.4 million concurrent players playing Modern Warfare, and they did that using the Amazon EC2 platform. So you can get a feel there for what's possible if you really evolve your load and performance testing to its logical limit. Okay, let's look now at rolling out into production. And this is another area where this idea of using lots of capacity when you need it has a lot of benefit. So consider a scenario like this where you've got an existing version of your application that's running in an AWS auto-scaling group, and you've got an elastic load balancer which is delivering traffic to that. But with AWS, it's perfectly possible at the point of deployment to create an entirely new auto-scaling group which has new versions of your application code installed on it, and you can see that notated here with that V2 notification, and then to add that to your ELB and to perform a controlled cutover between those two environments, phasing out traffic to auto-scaling group V1 and delivering your customers a new application experience at that point. And of course, at the point at which you turn off that version 1 of your application, you stop paying for that capacity. So we've seen this become almost the de facto deployment model that customers use on EC2 and on Amazon. When they want to create a new version of their application, they just build either an entirely new application server farm, or in some cases even an entirely new stack, as you'll see in this next slide. and they cut over to that new stack. And when they cut over, that is the point at which their application gets upgraded. And of course, as long as you minimize the period for which your application stacks are running in parallel, it will cost you no more than having one environment to do that. So it's a really commercially powerful tool, and a way in which you can do really good and advanced testing of your new environment without impacting your current customers or users before you cut over onto the new version of your application. This second example here shows this entirely duplicated environment model, and in this case Amazon Route 53 has been used, DNS-based traffic distribution, to distribute traffic between the new and old versions of this app, and to do that in a controlled way. And of course, at the point at which this customer is happy with the deployment and performance of version 2, they would change their routing algorithm, their DNS routing algorithm, and deliver all of their traffic to the second version of their app. So another way to achieve a very smooth and controlled application deployment, and to do that at low cost without needing to buy two environments. So we've talked there quite a lot about unlimited elastic capacity. We're going to have a look now at cost optimization and techniques that you can use for cost optimization on AWS. The most basic mechanism is to carefully consider the kind of instance purchasing that you're using. I'm sure some of you are familiar with this already, but there are three ways that you can acquire EC2 instances from AWS. The first is the on-demand instance. This is the default, where you simply pay as you go for the compute resources that you use. It's low cost, and it has very high flexibility. There's no upfront contract. So with on-demand instances, the hour you switch off the instance is the hour that you will stop paying for it. And it's good really for applications that have short-term, spiky or unpredictable workloads, and obviously for application development and testing where you might need environments for a short period of time. It's a really good fit for that. But you can drive your costs down if you need instances for a long period of time by using reserved instances. With this model, you pay a small upfront fee, and in return for that, you receive a significant hourly discount on that instance. So you would commit for a 1 or 3 year period, but importantly, you don't have to commit for a 24-hour-a-day period of operation. There is a low, medium, and heavy utilization tier within the reserved instances, and the heavy utilization tier represents 24-hour-a-day operations, but the other two tiers represent a reduced number of hours each day. So you can have a reserved instance that you prepay for a proportion of, which is only available for 8 hours a day, and you'd still get a significant cost reduction by doing that. So if you're going to have your development environment working through the day, as we'll see a bit later in this section, you can still buy your instances on the reserved instance type, and that'll still help you optimize your costs, even if the instances are shut down outside of working hours. And then lastly, there's something called the spot instance market. This allows you to bid on unused EC2 capacity. So there's a spot price based on supply and demand, which is determined automatically by the market, but it's typically a significant discount to either the on-demand or the reserved instance pricing. This is ideal for large-scale dynamic workloads where you want to optimize costs. So one example might be you want to run a large volume load test at some point over the next week, and you want to do that in the most cost-optimal manner. Well, you could use spot instances for that. Acquire the spot instances from the market at the point at which the cost is low, run your load test, save the results, and obviously you'd have those at the end of the week. So it's intended for non-time critical workloads. Now, of course, with Amazon Web Services, you can turn off services just as easily as you've turned them on. We've already talked about this quite extensively during today's session, but here you can see an example of CPU load in the development environment, and as is typical, people start coming into the office at 7 or 8 a.m. and by 2100 the environment is in a pretty much dormant state because their workers are no longer working on it. And in this particular example, by ceasing the environment outside of those core hours, there's a 25% saving available, and we would really encourage all customers to look hard at doing this. So there are a few techniques for it. One is to use auto-scaling by schedule, where you would scale down groups of instances to 0 or to very low numbers outside of core hours, and that would reduce costs. Another thing to do, of course, is to script this using the command line and tools like Cron or some other sort of job scheduler. and use that as a mechanism for powering down your environment, spinning down your environment, and then spinning your environment back up the following day. And we'll come to an example later on in the session of a customer that has done this to great effect and saved a lot of money by doing it. But the kind of premise really is switching off the environment can be as easy as switching off a light switch if you've done the right groundwork and set up the right policies and spend a little bit of time building some tools to do that and understand your environment and spin down your environment when you're not using it. So very, very good way to optimize your costs. So the last thing we're going to look at is environment preservation. So how you can use durable imaging and storage to preserve environments in the event that you need to roll back to them for some of the reasons that I've already discussed earlier in the session. So it's very easy with AWS to recreate an environment. So the ways and tools that you can use for that. Firstly, there's the ARMI, the Amazon Machine Image. Okay, so you can create an AMI of any instance, and you can store that AMI in S3, and you can recall that AMI at some point in the future and start another instance which is in exactly the same state as the AMI, as the instance was when that AMI was created from it. And importantly, you can attach these AMIs to instances of different sizes. So if you were doing load testing, you could snapshot your instances and create AMIs, and then later on for some regression tests, you could connect those to much smaller, lower cost instances. So you've got flexibility about what instance types you spin up those AMIs on, which is quite a powerful tool. Secondly, you can use snapshotting, and once again, we've already touched upon this very briefly. So this is similar to the kind of snapshotting that you might take using storage management tools. You can do it via the console, via the API, or via the command line. And this allows you to basically freeze the data set that's on a volume on a disk and to attach that, reattach that to another instance later on when you need to do so. And you can use that, of course, for boot or root volumes and also for data volumes. So you can use it as a mechanism for making multiple copies of data sets that you may want to access from a variety of different environments in the same way that you might do that with a traditional storage product. It's possible to do that with Amazon Web Services also, using snapshots. And lastly, you can recreate environments using templates. So this, as we've already talked about, using tools like CloudFormation, allows you to source control your infrastructure and to roll back to a specific known version that you've got stored within a source control repository. So a very powerful tool for dealing with things above the system level, the instance level, and dealing with a very wide variety of different AWS services and resources that you might depend upon in order to develop and test your applications. So there's three different options there that you have for allowing environment recreation. Of course, you can combine those things. You could have a CloudFormation template that leveraged custom armies that you'd already created for specific application tiers and attached specific snapshots in order to provide access to data. So a very, very powerful tool in combination. And together, those three things allow you to roll back and recreate environments to any given application version that you may have retained and may later specify. So a very powerful set of tooling. Okay, so we're going to close soon, but before we close, I just wanted to draw all this together into one case study, an example of a customer that's using AWS for large-scale development and test workloads today. This relates to a retail bank. It's actually in Australia, and I think looking at the registrations for today's webinar, we've probably got a few people from Australia and maybe even from New Zealand on the line today. So you guys will know who this is. But this is a large retail bank in Australia with about 20 billion in assets and about 250,000 customers. They've been using AWS since 2012 to enable them to refresh and transform their IT. So they've got a large number of parallel application development projects that are running, and they're using AWS for system integration testing, performance testing, and UAT environments. And they're using CloudFormation in order to enable that. So they say that CloudFormation provides agility that they need in order to keep pace with the bank's change program. And some of the benefits that they've managed to derive from doing that are pretty impressive. So they've gone from 3 to 150 developers, and they've only made very limited changes to processes and practices while they've done that. They automatically shut down their test environments at 11 p.m. each night and over weekends, and they estimate that by doing that they've saved 49% of their EC2 instance costs. They've also managed to drive down the lead time for new test environments from 6 weeks to less than a day. That's a pretty impressive stat using the AWS automation tools. And then lastly, they also say that they think that the benefits of on-time delivery, which is the principal area that they've benefited from using these tools in, has really managed to save them several $1 million in late delivery. It would have been incurred in the scenario of late delivery. So it's a good example of a customer that's got large-scale deployment of development and test on AWS today. And there's a reference there at the bottom of the slide to a URL. If you go to that URL, you'll find literally hundreds of examples of AWS customers, and there's a whole section there related to development and test workloads. So I really would encourage you to go there and find out more about what other customers are doing to support development and test on AWS today. Okay, so just to quickly summarize, we've covered in today's session a little bit of information about how using AWS can make development and test more easy than it is with traditional environments. We've talked about how you can make extensive cost savings by leveraging elasticity in development and test. We talked about some of the tool sets and frameworks that you can use to manage and create environments, and multiple environments at that. And we've also talked about how you can perform scaling activities for testing and other purposes that are beyond those that you could achieve in a traditional physical environment. So for further information, I've showed you already quite a few references to this, but if you visit aws.amazon.com, that's the main website for Amazon Web Services. You'll find a ton of info there, as well as some information about how you can get started with AWS for free if you want to try out or test any of the things that we've discussed in today's session. We're also, in the near future, going to have some in-person events that are taking place around the world, and you'll see there's several different locations that we're running these events in. If you visit the URL that you can see on the left-hand side of the page here, you'll find a full list of the events with the dates, and there's a Twitter account there that you can follow also, where we will provide a bulletin, an update, as and when registration is open for each of these events. So that's something that we're going to be running throughout 2014, the AWS Summits. And I've seen the agenda for these summits, and there will be content in the summits that is relevant to this development and test use case that we've been discussing today. So if you want to learn more about how existing customers are using AWS for development and test workloads, and also meet other people that are really doing it today, then I really encourage you to come along to one of those events and participate. They're free events, and you're welcome to register and join us at those. And if you're interested generally in staying up to date with what AWS is doing, both as far as events and news are concerned, and also as far as product announcements are concerned, you can find us on social media at the links that you can see on the page here. And of course, you can find me there as well. If you've got any feedback about the webinar today, I'd love to hear from you on Twitter. So send me a tweet, and I'll provide any further information that you're after if you do that, and I'd obviously welcome your feedback as well. So that concludes the material that we're going to present today. There are a couple of questions which we'll jump to in a second, but I'll just remind you that there's going to be a download and replay of this webinar available immediately after the session today, and of course these materials will be available for you as well with all the links in them. So we've got a few questions to look at. So questions to look at. Sorry, there's a question here that says, is there any way I can get notified when a registration opens for a particular summit event? The answer to that is to follow the Twitter account AWS Summits, and each one of the summits is notified via that Twitter account when it's open for registration. If you happen to be in the UK and you're interested in attending the London Summit, which is on the 30th of April, and the bulk of the registrants today are from the UK, by the way, that are on the webinar. If you go to the AWS_UKI Twitter account, which you'll have seen me link on the show on the previous slide, if you click the biography link on that Twitter account, that's an early way for you to access the summit registration page for the London Summit on the 30th of April. So visit us on Twitter, click the bio link, and you can register that. Okay, so there's a couple of other questions that I can quickly answer. One of them is, can you use Windows 7 for a testing environment? The answer to that is yes, you can run Windows 7 experience on one of the instances that we provide. It's not actually the Windows 7 operating system. It sits on top of a Windows Server environment, but the experience is identical to Windows 7. As far as I'm aware, there's full compatibility between the environments with the Windows 7 experience environment. But I will take your details from your registration. I'll come back to you with a little bit more information about that via email. And the last question that was asked was, how about licenses? So if you compare one instance for 100 hours versus 100 instances for 1 hour, the 100 instances must be licensed. Yeah, licensing is per time frame, so you don't have to buy the licenses in order to run those 100 instances for that 1 hour period. You just pay for the license by the hour as you use it, in the same way that you do the compute or storage resources that you use on AWS. The licensing is the same, and if you visit the AWS marketplace, which we've already touched on, you can also take a variety of third-party software products on an hourly basis as well. Okay, there's one other question here which is about OS X and Mac environment support. Unfortunately, we don't currently support OS X or the Mac environment on workspaces, and it's not possible at this stage to run it on an EC2 instance. So we support Mac client tools. So if you are a developer working on a Mac, you can use all the tools that you're familiar with, and you can push code, for example, from Eclipse running on a Mac up onto Beanstalk, or you can obviously push from the Mac to Git or GitHub and use that for deployment. But we don't support the macOS end-user environment at this stage, I'm afraid. And I think that is just about everything that we've got as far as questions go. If any more questions do come in, we will come back to you on those questions via email. And I think we'll conclude today's webinar today. I'll just thank you for your time. If you've got other questions, you can find me on Twitter. Just tweet me and I will send you my email address in the DM, or connect you with somebody else at AWS that can help you if it's not a question that I can answer. Okay. Thanks for attending today's session, and do remember to download the materials and find us on Twitter.